So in today's class, we're going to discuss about the types of multimedia network applications, streaming stored audio and video, conversational voice and video over the IP. IP is nothing but Internet Protocol. Streaming live audio and video, streaming of stored video, and UDP streaming, user datagram protocol using streaming it is possible. So these topics we're going to discuss. So multimedia networking, so basically three application types. So we can classify it as streaming of stored audio and video and conversational voice or video over IP and streaming of live audio and video. So what is meant by a streaming of stored audio and videos? So here, so streaming of stored audio means audio and video has to be stored so in the streaming servers. So streaming is nothing but, so we can begin to play out before downloading the entire file. So we have to, so play out is possible. So over the internet, so assume that streaming servers and requested client has been connected. So we can begin, so with the help of players, we can play out is possible before downloading the entire file. So the live streaming, it is also called as streaming. So a streaming server is sending the requested files. So for the requested users, so users already it is subscribed. So any audio and video so can able to play out. So entire file before downloading, that is possible because initial so audio and video the packets are buffered. So in the audio players or video players, and so rest of the packets has been sent by so the multimedia servers or streaming servers. So that is what we call as so the streaming of already stored so audio and videos in the streaming servers or multimedia servers. That is the one thing. So stored at the servers. So we are so normally so audio and videos so packets or audio and videos, so the files which are stored, so as you so different so that is files, so we can store at the servers. So to transmit very faster than audio and video has been rendered, it implies the storing and buffering at the client. It is so normally at the servers, it is a buffering is so at the client, it is implies storing so at the servers, and are buffering at the client. Normally it is, as I told, so initial parts of the audio and video packet has been buffered. So rest of the packet will be sent by, so that is so once it is internet connection is established between the streaming servers and requested client, the client machine is either it is so any IP based device supposed to use. So that should be, so it should be a laptop, it should be a desktop. So but it is a connectivity to be established between the streaming server or multimedia server to the requested clients. So we can request, so that is YouTube is the example for the stored at the servers. The servers has been maintained by the YouTube servers. So it is any the audio and videos files we can able to request to the particular servers. So definitely we can store the audio and videos we can able to. So they are streamed by the streaming servers. So we can continuously, we can watch out the videos and audios can able to hear. So to the YouTube. Even in the Netflix, it is another application. It is also available. Hulu is also available. Similar kind of applications. So that is exactly stored at the server. So this is one type of application. Another application, conversational voice or videos over the IPs, internet protocols. So here it is an interactive in nature. Conversational means so users can able to interact, nature of human to human conversation. So that is exactly, so video conferencing it is possible. So even audio conferencing, voice over IP applications, that is normally internet telephony, it is also possible. So even so telecommunication networks using that is exactly telecommunication peoples. So normally they are providing so normal that is a telephone device will be provided. Again, telephone lines are connected to the home networks, office networks, So here we can voice conversation, it is possible. So so it is a voice over IP nowadays we can see in the over the internet. So it is a very interactive in nature. There is applications which are available, that is a human to human conversation, it is a possible, and it is limits that delay tolerance. So even any audio and video packets can able to limits the delay tolerable. So Skype is the application. Skype is a, so it is a super nodes are available. Skype clients, another Skype clients connected by a super client, a super nodes. Even super nodes internet is a connect to another super nodes, making a overlay networks. So definitely it is a login servers are available in the Skype. In the Skype login servers, every clients, every Skype application clients can able to register and provide the authentication from the login servers. That is so that is some of the applications. So it's a Skype application. Once a login has been username and password is provided, definitely conversation has been made between the, so over the internet. So that is also called as voice over IP. So it is a internet. Communication is now how exactly we are doing in the telecommunication lines. So using mobile or your landline phone. So how exactly we can talk with each other with the help of so voice over IP, so internet telephony. So the conversation is possible between the two communicating parties. So that is conversational voice over videos. So even voice communication, even video conferencing possible over the, so IP over the internet, the telephone. So here, so that is another type of applications. So one more application, streaming the live audio and videos. As you know that, so that is any event is going on. So suppose if it is our prime minister, so it is some new things has been launched. It is addressed to the nation at that time. So live, so that is thing is going on that has been connected over the internet. So even we can able to, so the link is it is having a link, and is click on the hyperlink or double click on the hyperlink. Once it is that the PM office people will provide the link to you to entire nation and broadcast. So what is exactly it is going on, not only in the TVs, even in the internet, it can able to possible. So definitely once it is provided the hyperlinks, double click on the particular hyperlinks or multimedia servers, continuously stream out the live, so video conferencing what is done by our prime minister. Even so any live event like sporting event like football, cricket, now but it's a very popular games which is exactly it is going on. So we can entire so the cricket match, entire football match we can able to so we can so play out, so that possible, so over the internet. So it is a streaming server, it is continuously streamed out, so the audio and video packets, so to the requested clients. But you need to be subscribed. Sometimes it is a free of cost, it is also getting. So the live events like live sporting event is what exactly it is going on. That is another third application type, the streaming of live audio and videos. So in this we have learned the streaming of stored audio and videos, and how conversational voice or videos over the internet, so protocol applications, and streaming of live and live videos. So here streaming of stored videos. It is how exactly streaming of stored video. So that is one example I will provide you. So here, so videos which are stored, so that is a and streaming servers or multimedia servers. So video is encoded or recorded some rates. So encoding a rate or recorded rate 30 frames per second, for example, they have taken. So that is the encoding rate of recorded videos are stored in the streaming server or multimedia server. So when recorded rate, it is encoded rate we can call as, that is a constant bit rate. So always they are sending the streaming server, the constant bit rate it is exactly it is sending. So that is the recorded rate only, it is exactly sending. That recorded rate is a, assume that it is a, so for in one videos, so it is a, exactly it is recorded at 30 frames per second. So same constant bit rate has been sent by the streaming server or multimedia servers. So again, the video has been sent from the streaming servers, so over the communication networks. So there is a network delay is common. So because communication networks, So video has been broadcasted, or it is any client has been requested. So across the communication networks, so there is a interconnecting devices are available. Interconnecting devices like routers, many routers are servers. So through which your data has been passes. But routers, it is a processing delay. It is a commonly that is, even though it is audio and video packet is a urgent packets, it is a some amount of delay is guarantees over the network delay. So this is fixed. So in this example, so there is no delay. That is a no variable bit rate. It is exactly it is available. You will assume that in communication it works. The bandwidth is good. There is no delay is occurred. So fixed. So delay has been fixed here. Even communication it works. There is delay is common, but so in this example delay is fixed because there is a so your communication network channel bandwidth is good. So there is no delay is occurs. Whatever the so rate, video recorded rate and video that is encoded rate, for example, 30 frames per second. So that streaming server has been streamed out the video. That video has been sent over the communication network. So the network so delay has been fixed here. There is no network delay is occurs. So it is a receiver receive the so receiver. So where exactly it is receives. So receiver, there is a player, it is available. So in the receiver player, it is a buffer, it is available. So video is received at initially to the buffers of the so video player or audio players. So the initial buffers are 50%. I mean, in late class I will discuss. So initial so that is audio and video packet has been received to that. So 50% of audio and video packet is received. It is enough, and so from the buffer, so video whatever you are received can able to play out at the same constant bit rate, whatever encoded rate or whatever the sent rate. It is has been video has been sent by the so sent by the video servers, that is nothing but multimedia servers. So that rate only, so it is a play out. It is the video at the client side. So that is a multimedia. So client side, that is a video players. So that is, you can observe here 30 frames per second as a sent rate, same rate. So it has a it is a player that is a buffer has been sent so to the so exactly so audio or video player so has been sent. So that is the same rate. So that is a constant bit rate. That is a 30 frames per second. Here streaming at this time, client play out early part of the videos. So you see that. So as and when streaming is nothing but so early part of the videos which are initially stored in the so players. So that is a buffer. It is area. It is available in each of the players. So that is the early part of the videos which are it is so stored in the client so player buffers. And while servers, these streaming server or multimedia servers still sending the later part of the videos. So that is a streaming is so entire so that is video. So for example, video length is 720 so MB. So that so 30 frames per second. It is a constant bit rate. It is sent. So entire file has been sent. So that is a complete videos can able to so watch out. That is possible. So that is the same constant bit rate only. So the players, so the player buffer, it is sent back to the so that is in the requested client. So 30 frames per second. It is exactly play out is possible. So this is what we call a stored streaming of stored. It is a stored is nothing but already you have stored the audio and videos in the streaming server or multimedia server. So how exactly it is delivered by the constant bit rate. So how communication networks is delivered so without any delay. So at the same rate, whatever the constant bit rate, 30 frames per second, it is a encoding rate. So encoding rate is always equal to the constant bit rate. So that is exactly the send rate. The send rate is same even in the communication networks. So even in the player, so it is a sent to the so to the requested client. So that is a payout. It is possible at the constant bit rate, 30 frames per second. So that is the scenario. It is in stored streaming of stored videos. So streaming of stored videos have a challenges. So continuous playout, the constraint. Once the client is playout begins, so playback must match the original timings. But network delays are variable. So here, so the continuous playout, the constraint. Once the client playout begins, so playback must match the original timing. So whatever the constant bitrate is sending, same the original timing has to be matched at the client side also. So for example, 30 frames per second. So that is a constant bitrate is where the streaming server it is said same original. So that is a timing has to be matched. So same that is a constant bitrate only. It is a playout is possible. It is if it is a playout at the receiver side. Receiver is the client. So the sender is a multimedia server or streaming server. So that receiver is match the original timing. So there is no delay in the network. So there is no delay in the audio and video packets. But in the communication networks, delays are common. It is a variables. So if it is a invariable, it is a variable. Variable is nothing but variable bitrate. It is arrival of packet in the communication networks that it causes a jitter. So that is what we call as jitter. So if it is a network delays, so variations. What is variations? So suppose if it is a 30 frames per second, so it is a one. So it is a per second. It is a 30 frames. It appears. So if it is a 20 frames per second, so for the next second it is appears. So for example, 10 frames per second, next second, 5 frames per second. So like that, it is a variations in the arrival of packets from the streaming server or multimedia servers. There is a jitter problem we are facing. So we need to a client side buffer. It is a so that exactly it matches this playout requirement. So that client side is a buffer. So I will show you how client side buffer. So that has to be overcome. This kind of network delay has been occurred. So what is network delay? There is a variation in the arrival of packets. But earlier figure, whatever I showed, there is no variations in the arrival of packets. So, but so you can see that. So this is a constant bit rate only. So video 30 frames per second. Each second there is a 30 frames per second. But it is a each second. If it is a varies 30 frames per second. So next time it is a 20 frames per second. Next time 10 frames per second. Next time 5 frames. Next time no frames at all. So no frames. So this is the variations. So it is because of communication networks delay processing delay. It is in the networks in the routers. So it is due to the delays are common. So if it is a variation is arrival. So definitely to overcome this network jitter. So to maintain client side buffers to match this to match and initial. So how it is a match? I will explain you. So to match the playout requirements. So other challenges. So client interactivity. So exactly users can interact so with a particular application. So exactly I think it is a so VCR like application it is available. So we can pause the so videos. So we can fast forward the videos and rewind the videos and jump through the so one screen to other screen or jump through the videos. So whichever the frame you like, whichever the screen you like, so that the frame you can able to jump. So this interactive application, so that is exactly expected by the so again the users or the clients. So normally the video packet sometime may be last. So as and when video packet is last, so again it is a client side. So streaming server it is sending some packets. So those packet, so whichever the packet is appears, so may not be known by the users. So we can identify by the receiver side, so the client side. So which packet has been lost, so can able to retransmit. So that is the reason it is a sequence numbers has been maintained for each and every packets for the audio or video packet. So we can identify that. So that is a protocol it is available. The protocol can identify the each and every so that is a received packet. So that is exactly so if it is any packet is lost, so that has to be retransmitted. So that is a we can identify with the help of sequence number or it is a timestamp. It is going to be so it is a very useful for so identification of the packet loss. So next discussion is so this is a streaming stored video again revisited. So again you can see that whatever I explained. So constant bitrate of video transmission by the multimedia server or streaming servers. So that is exactly so 30 frames per second. Assume that example is given 30 frames per second. So here so over the communication networks delays are guarantees. So because it is a many so communication networks through which so many communication network interconnecting devices through which your data has to be arrived. It is not direct receiver of your data. So your routers routing delays are normal commonly processing delays, and also it is a which so that is a route has to be selected. That is the processing delays for packets and routing of packets delays. So that normally it is a common. So that is causes a jitter. So you see that how client video packet has variations in reception of the videos. Sometimes instead of 30, so every time it is not 30 frames per second it is arrived. So already I told. So 1 second it is arrived 30 frames per second. Another second there is a 2 frames per second. Another second 2 frames. Another second 2 frames per second. So again 20 frames per second. 10 frames 20 frames per second. It is like that. Each time it is a varies. Whatever the how much of time it is exactly it is streaming. So that time exactly, that is the reason next axis the time they have taken, it is a cumulative data. So entire data has been, so data should be either the so 30 MB videos or the 720 MB videos. So it is already stored in the streaming server. So that as a cumulative data has been taken in the y-axis, that is stored already in the streaming server or multimedia servers. So not only videos, it is audio, so it is also same thing. Audio, so that is a multimedia. So server will stream out the audio and video. That is so at the constant bitrate only. It is a science, and so that is a communication networks. Commonly, it is a delays are common. So it is how client video reception has been shown here. So that is it should be so causes a jitter. So it is a invariation in arrival of a packet. So that is a variable bitrate only. We are receiving the packets of videos. So once it is received the variable bitrate, so that has to be overcome with the so buffered buffering has been done with the videos. So here client side, so that is a so player is available. So audio player for audio packets has been received. So video player and the player application, there is a buffer area is available. So it is a before playout the so that is audio and packets and video packet. So initial parts of the videos can be able to, so that shall be stored in the buffers, and later part of the so audio or video packet has to be received by from the streaming servers. So 50% so of the videos or audio or video packet has been stored in the so the client side, so the buffer, it is a audio player, it is a buffer, it is available. So that is the initial part of the videos which are, has been stored. So 50% of the, so it is has been stored, 30 to 50% if it is stored, the buffer that is already it is audio or video packet. So definitely, so with the buffer, the client playout, so that is possible. So with the constant bitrate only, constant bitrate. So that is the 30 frames per second has been compensated. So that is a video playout at the client. So constant bitrate only. So that bitrate has to be, so this constant bitrate, whatever the sending rate, so that is a receiver playout. So receiver, the sender is always, it is a audio multimedia server or streaming server. So it is exactly a receiver is a client. The client is any requested so client so requested the particular videos. So exactly payout at the constant bitrate. So that is a payout at the so constant bitrate only. Here, the client side buffering is very, very important. So client side buffering and playout delays so can able to so overcome and compensate for the network added delays, and these delay jitters, any network added communication network added delays, processing delays, queuing delays, so many delays are we can observe. So these delays can be overcome, and jitters in variation in arrival of so that has to be compensated by a client side buffering, so has to be made. So here client side buffering, it is a detailed discussion. You see that, so how exactly client side buffering has been made. So either it is a video servers, videos files which are stored here, audio and video files which are stored here. So it is a continuously stream out. So at some constant rate only. So it is a, assume that already I told it is a 30 frames per second. It is a sending over the communication networks. This is a communication networks. So there is a many routers are available, many servers through which even service mode server through which your data is delayed, data is received by the receiver. This is exactly requested clients. So the client has been requested the particular video. So request is goes to over the communication networks to the video server. Video server requested file is it is available. Definitely it is a streamed out the stored audio and videos from the video servers. So definitely it is already it is a video servers. So audio and video packet is available. You are requested the video file, it is available. So video server, it is a stream. So over the communication networks, in the communication networks, the routers, many routers, many internet service providers, servers are available through which only data is received. It is not direct communication to the client. So as so communication networks. So communication networks, that is exactly the delays are common. So variable, so you see that variable bitrate it is available. So that is a x of t. That is a so fill rate. So variable bitrate of arrival of packets to be fill rate at x of t. So here there is a buffer fill level, it is a q of t. So here it is a, so already I told, so in the client side it is a buffering, it is to be maintained at the so player. So in the player, that is a client side application, that is the buffer size is available. Buffer size we call as a b. So this is exactly the fill rate, buffer fill level, at least 30 to 50% of the buffer, it is a fill level. So that from the buffer, so before play out the video, so once it is filled 30 to 50% of the so initial there's a fill by the audio and video packet which are sent by the video server. So rest of the audio and video exactly it is sent by the cumulative data has been sent to the so our streaming to the even variable bitrate is arrival. So it is overcome by the so by the so initial buffers or client side buffer, and it is a play out at the before play out the videos. So even play out it is so it is a play out the rate is constant. So here play out rate is a constant bit rate. So that is exactly it is possible. So this constant bit rate and whatever sending rate is also a constant bit rate. If it is matches, there is no flickering in the audios and video. So play out it is possible. So here, so that is the client side buffering. How play out it is so has been shown here. So even client-side buffering, so the playout has been initial fill out the buffers. So you see that so video server or audio and video are available in the video servers. As you know that the communication networks, so that is delays are common. So it is a video server sending the constant bit rate. So 30 frames per second, for example. So even fill rate it is nominated as x of t. So it is a variable level. So variable bit rate is nothing but it is sometimes 30 frames per second. It is arrival sometimes 20 frames per second, and then another time it is a 5 packets, 5 frames per second. So like that, if it is a variations in the arrival of packet, it is a jitter problem we are facing. So that has to be overcome. So here in this example, a buffer fill level Q of t, it is so always draining. So the initial fill buffer it is until playout begins. So so before playout begins at a certain time T of P. So playout at begin at P of P. Initial buffer fill level should be varies over the fill rate. So if it is a varies, so and playout rate is so constant. So you see that at least 30%. So if it is a fill level, it is so it is already it is training. So if it is a constant bit rate, is a so at least 50% of the fill rate, 30 to 50% it is fill rate. It is available. So constant bit rate it is here almost it is draining your buffer. So that has to be so that is already some how much of the fill rate it should be expected by the buffers by the client side. So that is already it is calculated at least 30 to 50% of the fill rate. So it should be filled. So should not drain the buffers. That is a buffer is nothing but storage of area of the particular audio and video packets of the client side application. So that is a so that it should be a constant rate has to be maintained. So it is a constant bit rate of playout. Okay. So the videos, audios, and video packet. So expected by that. Again, it is a so the client. So without any audio and video, the flickering we can able to watch out. If it is a draining, so definitely in the next time, so your videos is keep on so moving. So before so arrival of packet is cannot able to play out. If it is a so at least 30 to 50% it is filled. So we can definitely play out without any. So that is a flickering in the images without any audio disturbance we can able to hear. So here client side buffering, so there is some more discussion. So buffer eventually empties. It is so suppose earlier so figure you have shown that it is a causing freezing of video playout until buffer it is again fills. So again has to be filled the buffer area. So if it is a freezes the so buffer level, it is a constant bit rate of so playout it is not possible. So that buffer will not make it is empty, provided initial playout delay is large enough. If it is so large enough initial, so suppose if it is a variable of arrival of packets is large enough, it is should be observed variability in x of t. So it should be what is the how much of variability variable arrival of packets so to the so players. So that is a player buffer you should also observe. So it is what is exactly so x of t should always greater than r. So that is exactly buffer should not empty. So x is so greater than r, it is eventually empty. So that is r is the rate of constant bit rate. So to play out, so this should be greater. So what happens? So your constant bit rate of so watching the constant bit rate only, expecting so without any audio and video, so without any disturbance, so we can able to watch out. If it is a x of t, it is a variable bit rate, it is a less than so r, it is a r is greater now, so it is a buffer eventually empty. So it is empty, causing freezing of video playout until so buffer again has to fill. So it is exactly draining of the videos is going to be happen in the buffer level. So it is again fill out. So if it is constant bit rate only, it is so again playout that is possible. Here if it is x of t is greater than r, so buffer will not empty. So you see that the buffer it is not empty, provided the initial playout delay is large enough, and if you observe the variability in so variability initial rate should be large enough. It is a so variable fill rate should be filled at least 30 to 50% of the client side application. So we can play out so without any flickering in the images, without any audio disturbance, we can able to play out the audio or video applications, audio and video. So that is a package. So here that is so audio and videos we can able to watch out very clearly. So here, so initial playout delays, what is exactly the disadvantages? Buffer starvation is less likely in larger delays. Starvation is occurs so very less. So with the larger delays has been occurred, but larger delays until user begins watching. So as and when larger delays occurs, so until the user begins watching, so initial playout buffer is keep on trying. I think it is you maintain this so as a okay so trade-off. This is exactly disadvantages. So that should be maintained. So in the client side application, so the buffer fill level. Okay. Streaming multimedia so over the so UDP protocol. So server sends at the rate of appropriate for the client. So often send rate. So already I told send rate is a constant bit rate. So 30 frames per second. That should be encoded rate. Encoded rate is also 30 frames per second. So assume that it is a server, multimedia servers or streaming server send rate appropriate for the client. So client rate is also client playout rate is also constant bit rate. So they're expecting that is a send rate is always encoded rate. Encoded rate is nothing but video should be encoded or recorded. So assume that the 30 frames per second. So video has been recorded. Send rate is also 30 frames per second, even constant. So when we play out the particular videos 30 frames per second only. So the constant bit rate only we are play out. It is possible. I play out so the videos. So then there is no so flickering in the images. We can watch out so any delays. So here transmission rate can be obvious to congestion levels. So even transmission rate, so it is a constant bit rate only. It is assigned. So, but sometimes it is obvious that it should be a congestion is levels are guaranteed due to communication delay. Your congestions, so your bandwidth is not good. So congestions may occur. So that is a communication networks. So that is a processing delays are occurred. So due to even bandwidth, so if it is not good, congestion is guaranteed. If bandwidth is good, so initial payout, so initial streamed packets has been filled in the right side buffering that is possible. Some shorter playout delays. So it is some 2 to 5 seconds shorter short playout delays to remove the network jitter, and error recovery application level time is permitting. So here it is a so RTP, real time transfer protocol. So it is a so real time so protocol. It is a real time applications like internet telephony, voice over IPs, and RFC 2326 multimedia playout. That is a payload types are available. UDP may not go through that. So exactly a firewalls. So it is a so exactly you user data may not disturb any UDP packets cannot be able to reject or stop by the your firewalls. Firewall is a packet filtering device. I think to each and every packets has been checked by the firewall because it is the function of the firewall device. Anyhow, so that's all about this discussion. In this class, we have discussed about what are the types of video network application, streaming of stored audio and video, conversational voice audio over IP, streaming of live audio and video, streaming of stored videos, and UDP streaming.